All right, good morning, everybody.
Good morning.
Welcome to the March CADimensions morning show. My name is Tom DeLaura. I'm a technical solutions specialist.
And my name is Jeff Lewis. I'm the sales operations guy for our 3D printer division.
Fancy title.
It's fancy.
Nice.
A lot of purpose.
For this edition of the show, we will be talking about 3D printing using SolidWorks and how they connect to one another, how a part is created in SolidWorks and passed over to the printer side of the house and actually printed. Some quick administrative stuff. Some updates for CADimensions. Our new blog has gone live. This is super exciting. We have about 10 posts in there now. What we're going to be using the blog for is tips and tricks, some user event updates, any CADimension events that are upcoming, product details, anything helpful to our customers out there, you guys. You can go to the blog, check it out, learn from some of our AEs. It's been pretty successful so far. We also have our SolidWorks User Group Technical Summit coming to upstate New York, which last year I know was down in Pennsylvania. We're very excited to be hosting it and having one of our user groups hosting it out in Albany. So on April 29th at Siena College in Albany, we'll be holding this technical summit, which is treated like a mini SolidWorks world. So we'll have, I believe it's 8 presenters talking throughout the day. All information and the registration can be found on our blog. Look at that tie-in right to the blog.
Everything's on the blog.
We love the blog. Final note, if you're in Central New York, our Syracuse office is hosting an open house, which we bring our customers in. We show you where all the employees of CADimensions work. We go through our printer. We go through our training rooms. We actually have a little meet and greet and Stump the Chump challenges where you get to talk to some of our experts and learn about the products CADimensions has to offer and where we operate out of. Rochester had one last month. It was very successful. I think a lot of our customers got some good feedback from what we actually do. CADimensions is deceptive, and I'm sure most of our SolidWorks customers didn't realize we have 3D printing. So
I still don't know what you do.
Exactly. So I like it that way. I'll keep you guessing. So a great event. You can register right on our website, and there's the link. If you can't really click it, but it's there.
On the blog.
All right, so that's our CADimensions news. Now, what are we doing here today? Our agenda. What we're going to go through today is part creation in SolidWorks and using some feedback from SolidWorks simulation to update a prototype, actually create an STL to export that prototype, hand it over to Jeff so he can print it for me, and talk about the various methods of printing and technologies. We also have a community user, Mike Cimino from the Fayetteville Free Library, will be calling in here, and hopefully we'll get his webcam up and running. And he's going to talk about some of the work he does with SolidWorks and 3D printing at the Fayetteville Free Library. Finally, we're going to wrap up with what's new in 3D printing, some new technology and materials.
Very exciting.
Super exciting. Perfect. Cannot wait. All right. First things first, let's go here. Real bland slide.
Boring slide.
It's a boring slide. That's because I'm going to jump into SolidWorks. Get out of this PowerPoint stuff. So, Jeff, look what I designed.
I don't know what it is.
It's a boom.
It's a boom.
So this is a part of a, it's called a resin machine, which helps people who do mining. It protects, so at the end of this boom, there would be a grate that protects people from rocks falling in caves.
It's important.
It's a very important boom.
Safety tool.
It's a sweet name. What I designed on this boom is this knuckle.
It's a small part.
It's a small part of a big assembly, but it's very important because it controls all these hydraulics. So I have to make sure that I have the right mass, the right support, the right, all the guts to this part. I have to make sure I engineer correctly. So this boom does not fail. I don't want a cave falling on somebody. That's on me. That's really on this knuckle. So I have taken this design. I'm happy with it. I'm pretty sure it's perfect. And I sent it out and had your guys print me a prototype. So they printed me this nice prototype.
Nice
It's a
blue.
nice looking prototype. I'm happy. I'm going to my boss. I'm saying, this is the knuckle.
It's a good knuckle.
It's exciting. So I'm on my way to my boss. My phone vibrates. I get an email from our analysis guys.
Never good.
They were really smart guys. So what they sent me is this video saying, hey, Tom, good try, but your knuckle's not really optimized yet.
It's not good. Not a good knuckle.
It's an okay knuckle, but it's not optimized. So they sent me this very detailed video, and they're using SolidWorks simulation during this to go through and run an FEA analysis on this knuckle. And what they're going to do is use that tool to say, is this really the best knuckle for my boom lift? So what they did, they looked at the stresses that are coming through here and what are supporting the hydraulics of my knuckle. They ran it. It looks pretty good as a sub-assembly here. The pin that supports the hydraulics there's no red, so that's promising. Some of the insides have a little red, and down here, some little red, but nothing to the point of failure. So this knuckle's okay. But really, when we look at it as an individual, we realize maybe it can be a little bit better.
Everything is better.
As an engineer, I agree with you. Everything can be a little bit better. So running this analysis, we're going to compare it to our full assembly and our individual part and make sure that we're not missing any pieces as far as an analysis goes. We want to make sure that every piece that we're touching is correctly analyzed and that we're editing the part in the best possible way. So again, we're trying to optimize this part to be the best knuckle
It can be.
it can be. It's like be all you can be. It's a great slogan for knuckles. So the analysis is run. On the left side, we have our full assembly. On our right side, we have our individual knuckle. We can see that our analysis is pretty close for both of them. So now we want to optimize this part. We know it's not going to fail in the field, but we do want to optimize it. So what we can see is our radius here is pretty wide. So we're using up a lot of material in this area, and it can be better. So what the FEA guys ended up sending me was this analysis saying, hey, maybe you should come back and look at this radius. We can probably reduce the weight of this, keep our efficiency, and reduce the cost of our overall product. And as you saw in the boom, we have multiples of these. So the money we can save on one is going to translate to the money that we can save on all of them.
It's very important.
It's very important.
Money is important.
Your feedback in this situation is wonderful. So what I'm going to do is jump back into SolidWorks and actually come in and look at the analysis they sent me and try to tweak my knuckle. So the design study they sent went through 9 iterations of different settings. So they played with a radius anywhere between 10 millimeters and 40 millimeters. They played with the width between these two arms, anywhere between 10 and 30 millimeters. And they wanted to keep the stress of this under 250 because that's when we saw the red. So we know that the red at 250, this product's going to start to bend and give a little bit. We really want a sound product. And our end goal here was to minimize our mass. So we want to make the cheapest and strongest product that we can. So given these optimal settings, out of all 9 iterations, our radius really needs to be reduced down to 10.29 to be precise, but I think we're going to be okay with 10.
I hope you're right.
I hope I'm right too, because again, imploding caves is very dangerous, especially in Syracuse.
Big mining community.
So I now have my part, and I'm able to edit it right out of SolidWorks. So I know it's going to be this radius. I'm going to click Edit Feature, drop it down to 10, make sure that looks like my optimal setting, accept it. That looks pretty good. Now I'm happy. I'm ready to go to the boss with my new prototype. So can you print this for me now?
Not yet, Tom. I need an STL file.
Always forget about the STL file.
Most important thing in printing.
It really is. All right. So, even though I had my part, it's really not ready yet. What I need is an STL. And what everybody out there needs to know is, what the heck's an STL?
Get that question every day. What is that?
So an STL is a file type that all 3D printers really use.
Pretty much universal.
It's a universal file type. And what it's doing is pretty much creating information of a 3D model by approximating multitudes of triangles across this product. So it's going to translate the data of your 3D model, regardless of program. SolidWorks is very good at creating this STL, and giving it a file type that can be sent to a printer and actually printed. But before you just click Create STL, you want to do a little research into how to optimize your STL.
STL file is just as important as the actual printer itself.
Is it
Start
really?
with a bad file, you're not going to get a good print.
Exactly. I'm sure you've seen many failed prints from a bad STL file.
Every day.
Every day.
Every day.
So the 7 key optimization settings for an STL file would be the angle deviation and chord height, which SolidWorks really has very good settings for. And these are really the most important because this is the precision of your part. These other 6 are design characteristics. So wall thickness, you want to make sure that you're able to print using the printed material. A surface is too thin, it really has no weight, so the printer's not going to see that as anything. So you want to really make your walls thick enough. What's the minimum distance?
It's going to depend on your wall thickness, but typically 40 thou minimum wall is recommended.
So 40 thou, around a millimeter.
Mm-hmm.
So pretty small, but it still has to be there for enough weight to make sure you get a solid part. And then as your assemblies get more and more complex, there's ways to save out an STL as an assembly, so it's not looking at a part or an assembly as a single part. So where it gets too close and you're under that millimeter, it might start to assume that it's a solid part where it's really 3 parts working together. So just some things to think about when you're creating that STL. So because I'm now under a deadline and I need this part printed, I'm going to go ahead and create an STL for Jeff so he can get off my back here.
I need something to start with.
I know.
I can't do it all.
I know. So under File, Save As. I'm going to save as a copy. Instead of saving out as a part, SolidWorks, as you know, gives you a plethora, that word,
A lot of choices.
of features
I don't know what those are.
that you can save out as. You don't know what these are because you only care about the STL.
That's true.
It's the most important part.
It's very important to me.
So I'm going to make my my knuckle for Jeff. Save it out to my desktop. But just saving out the STL isn't the only thing. As I was saying, there's options here. Wait, you can't see. There we go. There's options here. There's a couple different output types. Binary is going to be your most common. ASCII is a different type that generates your content a little differently. Both are printable, but binary is just what we see. So now you have some options between coarse, fine, and custom. So this deviation and angle is going to be what generates your 3D model and the quality of that 3D model. So a coarse selection here, as you can see, my rounded edges aren't round.
Lots of faceting on that.
A lot of faceting. When I go into my fine, this is looking pretty good. I got an angle about 10, a tolerance of, what's that, 1.15. Still not bad. When I can come into custom though, this is when I can start tweaking it to find that perfect area. So right now, I'm at my minimum angle, which is the best part, that's a 1/2 degree, and I'm at my smallest tolerance, which is at 1/100. So real small tolerance there. However, what you'll notice here is the number of triangles that I just created between fine, which is right around 8,000, and custom. Let me tweak that back up to the best. Still crunching because it's creating all those triangles. Now I'm up around 1 million.
It's a lot more
It's
triangles.
a lot more triangles, and those triangles directly relate into our file size. So what I'm going to look for is this fine setting, which is kind of that happy medium between.
It's always good to find the happy medium.
Always good to find that happy medium.
The larger file you have, the larger it takes our software and the printer side to process it.
Exactly.
And find that happy medium. Best bet.
And at the end of the day, that maximum with a huge file size is really going to look very similar to that fine.
It's going to be very hard to tell.
Right. Just a quick example of what those look like. So here's a sphere with a coarse setting, a fine setting, and a best setting. So our sphere here, lots of faceting. It doesn't even look round. You have flat faces all over the place. From those triangles, doing the best they can with the settings. But with an angle of 30, you're not really going to get that shape. Our fine does look pretty good. It definitely looks like a sphere. There's some faceting, but that may not come out in the print job.
It may not. The first one definitely would.
The first one would be
You would see that. And people would blame the printer when it's actually their file. That is the bad thing.
Exactly. I'm sure you get many a call saying, this printer is garbage. It's really that STL file.
It is the STL file. It's the STL file fault.
And our final setting here is the best setting, which is the 0.5 degrees with a, I don't even know what that is, 2/10,000ths of an inch. But our file size jumps from 300 megs all the way up to 25 gigs. So if you're trying to send this out to a customer, if you're trying to actually just process this alone,
It'll take some time.
It'll definitely take some time. You'll get a clean product, but is it worth it, or are you okay with that fine? Again, you're always looking for that happy medium.
Happy medium.
All right, Jeff, so I'm going to save out my STL file. I got my fine setting. I'm happy with that. I'm going to click OK. Save it to my desktop. Look at that. You can see all the triangles. You can start to see what this product's going to look like when it prints. Can I print now?
Well, before you print, you got your STL file. You have the most important part. We kind of have to decide, what are you looking for out of the part? What's important? And what technology would be best suited to print this model that you need? Do you need functionality? Do you need good aesthetics? Do you need smooth surface finish? Do you need rubber-like materials? A lot of different options that we have out there that you can examine and kind of decide what option would be best for you on each individual part.
So I didn't really get those options with this part. I just said print them, and this is what they gave me. So can you explain some of those options for me?
Yeah. We can go through the two different technologies that we have to offer. The first technology is going to be the PolyJet technology, which is one that a lot of people aren't that familiar with. It is a technology that's based off the inkjet. So it's very similar to an inkjet printer, and the idea that we're using an inkjet head that's jetting little balls of photopolymer, and then it's curing that by UV light.
UV light.
It's not good for you.
Very fair skin. I have to be very cautious of UV light.
That's why we keep you away from the machine.
That makes sense.
There's no danger. Not going to get sunburned by staying next to the machine.
I'm going to wear sunscreen just in case.
But the PolyJet systems print very fine detail, where on other technologies we're printing it like 10,000ths. On the PolyJet side, we're printing the 16 to 30 microns, so very, very, very small. And we're able to print in flexible rubber-like materials as well as transparent materials and a wide variety of different types of materials, so we can simulate a lot of different plastics. It's really meant for the companies who are looking for a nice-looking prototype right off the machine, very detailed, and aren't going to require a lot of mechanical capabilities out of the product.
Gotcha. But I don't know if that's the best for my knuckle. I mean, this has got to be in that boom. I need some.
So you're going to need some functionality.
I need some stiffness. I need some real mechanical properties.
Well, on the other side of the fence, we have what's called our FDM technology.
FD what?
FDM stands for Fused Deposition Modeling. This is probably the most common technology that people are aware of for 3D printing because it's the one that's involved in all of our consumer products you see out there, like the MakerBots or the kits that you see. What this is basically think of an extremely accurate hot glue gun that's extruding thermoplastics. So our material starts out in filament form, if you can see it.
Oh, looks like weed whacker stuff.
Yeah, weed whacker line will not work. It does break your machine. People have tried it. It does not work. It's a special formula that they've come up with. But basically, you take that spool of material, you put it in your machine. It's heated, put it into a semi-molten state, extrude it through a small diameter tip, as you see on that screen, and it lays it down layer by layer onto a build platform. And it toggles back between model and support. The neat thing about FDM is that we're dealing with thermoplastics. We're dealing with the real materials. On the PolyJet side, we were dealing with materials that were simulating plastics. On the FDM side, we're actually dealing with real thermoplastics. So we can get high-performance plastics that are industry-ready, so you actually can take that knuckle out and field test it in the real environment and see if your design is going to stand up.
Perfect. So what material do I want for my knuckle?
Well, that's the next question, Tom. There's a lot of materials out there that we have for you to choose from.
Goodness.
So on the FDM side, we have a wide range of different materials, different thermoplastics, many different grades of plastics, from standard to engineering to even some high-performance plastics. In our standard plastics, we have our ABS M30 or ABS Plus, and that is pretty much our go-to material. It runs on all of our FDM systems. ABS is one of the most injection molded materials in the world, and for the most part fits everyone's needs for functional testing, concept modeling. It's a really well-rounded material. So Tom, got a little stick here. Is that going to be strong enough for you?
I mean, this looks pretty good. It's got some flexibility. Josh,
Great. Don't know what I had.
Josh, I mean, my knuckle's saving lives, and you're giving me a part that I can snap?
Well, hey, you never know. Well, maybe we'll try something else.
All
So
right.
maybe we'll move into our engineering plastics and see what we have up there.
Maybe that would be better for me.
One of the newest things we have is the Nylon 12.
That sounds cool.
Yeah, nylon is a very popular material for companies out there. Obviously, the great thing about nylon is its flexibility and its resistance to break. So, I mean, let's see if we can break that one.
All right, let's look at this guy. Whoa. Now we're talking. It's unbreakable, Jeff.
Got some good flexibility.
Some really good flexibility, but imagine my knuckle being all flexible like that. I mean, if the
Might not work
hydraulics
out
will
well.
bend it, that's still not the right part for me.
Okay.
What else you got?
Well, we can step into our high-performance plastics if you're really looking for some tough, durable stuff.
That's what I'm talking about.
So in our high-performance, we have a plastic called Altem 9085.
That sounds fancy.
It is fancy. So Altem was developed for the aerospace industry, and the reason it was used in the aerospace industry because it comes with an FST certification, which means that it can go directly in the aircraft because if it catches on fire, it won't give off any toxins. But what we found is actually the most well-rounded mechanically for our materials, and that's a very, very strong product, chemical resistant, high heat deflection temperature. And so, Tom, let's see if you can break that one. See, I set you up for failure.
I mean, that one is superior to
It is.
most.
People are actually using this for metal form.
Really?
Yeah, foreign meat shuttle.
Meat.
Meat shuttle. Sheet metal
Sheet metal, that makes
over
sense.
Altem tools, 10,000 psi.
I mean, 10,000 psi, I'm looking at 250 psi for that.
Okay.
I think the all-time might be a
Little too fancy?
little too
Little
much.
lions for you?
Little too much for
What lions?
my knuckle. I understand you're saving lives, but I'm still under a budget here.
All right. Well, what we can do is we can pop back down to our engineering area. We can look at some other options in there. One of our most popular options is the polycarbonate material. Polycarbonate, well known in the manufacturing industry, used in a lot of different products. Very strong, durable, kind of that happy medium between ABS and Altem. Has a great, strength, tensile strength, 5,000 psi for metal forming. So it could be a good option for you.
Nice. I think that's my winner.
Okay.
Can I have it now?
Well, now we got to take that STL file that you made it a while ago
Yep.
and process it.
Process it now.
Yes.
What do you use for that?
Well, all of our systems come with a pre-processing software, which is basically a print driver. And what this does is this is where you're going to orient your model, process it, create your tool pass. It's very simple. So over here you'll see Catalyst. Catalyst runs on our FDM systems, one of the ones that we have. They all have the same idea on what you're doing. So basically I'm going to go File, Open STL. I'm going to find that file that Tom made. Dirty desktop here.
That's where I got a lot going on.
Bring it in. Tom, it's a little big. A little big for the machine I have.
Yeah.
Let's scale that down.
That could be my design.
Okay. Yeah, designer fault. So you can see every time you bring an STL file in, it's actually going to bring it in an orientation in which it was exported out of your software. And that orientation is not necessarily going to be your best option. But before you do that, you have a couple different options when you're dealing with systems. You can choose different layer thicknesses. This is dependent on the machine you're using as well as the material. 10,000s for our FDM system is usually the go-to one. But for your case, if you're functionally testing this, we're going to want to use a solid interior. I'm not going to want a honeycomb, so we need nice and strong.
Oh, nice and strong.
We want the inches, we want one copy. We're going to use the smart support, so it's going to use the least amount of support material it can.
Nice. But, I mean, with your orientation there, isn't this all going to be support material
It's good.
here?
Yes,
I
it's
can't
going to.
just float here.
I can't build something in 3D space without supporting it.
But is that the most cost effective?
It may not be.
It may not be. I mean,
So orientation, Tom, is the biggest learning curve for when using additive manufacturing or a 3D printer. It's going to affect your build time, your strength in X, Y, and Z, as well as the amount of material you use. So if I was looking at this part and I didn't want to have to support this whole angle, I would think, okay, there's a new orientation that would be better for this. So what I can do here is select this, select the face. Bam, there you go.
that makes more sense.
So this is all going to be self-supporting, and I'm only going to have support material here and then on the bottom. Cool. So once I select the orientation that I want to build in, all I have to do is hit Process STL. And the software is automatically going to create the toolpaths needed for my model as well as the support material. So it's all hands-off. So we're talking 15, 30 seconds, maybe a little bit more with a complicated part.
That explains why even you can do this.
This is why I can do this. The red material here is going to be your model material, the actual object you're building, and this purplish gray is going to be your support material. So once you have it processed, all you have to do is add it to your pack. And what the pack is basically your build platform. So this is actually what it looks like, what your tray would look like on your build, on your actual system. So you can move it around wherever you want. You can bring all the files in here, and all you're going to do is hit print. And if it was connected to a printer, it would send it over there, and all you have to do is go hit the print button and go home for the day and not worry about anything. So it's pretty simple.
Perfect. So I know we got a printer right over there.
We do. We have a couple.
We got a couple right in the house. So hit print. I'm ready for my model. I got to go see my boss.
There you go. Print.
Can I have my model? Now we're talking. I got my new shape. I got my minimum radius. This one's way lighter than this
Way
one.
later.
And it's SU colors. So
SU colors.
I'm a happy guy now. I'm going to go see my boss with this guy. In the meantime, we're going to pass it over to our community visitor today. We have Mike Cimino. You might have saw a new face pop up in your video there. Mike, I think you got audio.
Hi guys, how are you?
We're doing
Thanks for
well.
having me.
Thanks for joining us.
Yeah, absolutely.
So, Mike, tell us a little about what you do over at that Fayetteville 3 library.
Yeah, well, what's really exciting here is that we have 8 total 3D printers. We have the MakerBot Replicator 2s, Replicator 2X, couple old Thingamatics, and we got a 3D Touch. But really we see the most use out of the replicators. And what was nice was that we now have SolidWorks, a 2012-13 license, actually from you guys there. And you guys have been very helpful with setting it up and some training. And what we've been trying to do is trying to get the community interested in 3D design and getting them to kind of get the layout of the software itself, what is 3D design and how it works. And it's starting to take off. We've only been open since September, but we now have a adult robotics club, and they're kind of embracing that SolidWorks design components into making like wheel hubs and gears for their motors, some of the casing. So it's been pretty exciting what they're doing.
So they're going design to print to an actual assembly right in the library?
Yeah. I mean, we're I mean, all the printers we have are fused deposition, so your FDM modeling. But they're making a mascot for the Fab Lab. That's their first project, and they have it. They have an aluminum body and some things, but right now the wheel hubs are just were printed the other day. They're on, actually in PLA. They're trying. They may go to an ABS, but those were made on SolidWorks. They've been tweaking them, changing some of the settings that you guys showed, and creating that STL file. We don't use the Catalyst program for printing. We just use Makerware.
Yep.
So we're a little limited in some of your compared to you guys.
Capabilities.
We have infill and rafts, and that's about it, you know. But it works, you know, and it's been so far successful. They haven't broken any parts they've made yet, so
Perfect.
they may be over-engineering.
I'll send Tom over. He can break some.
Yeah, right, absolutely. So that's been really kind of neat. And we have the classes that the library does. They're free of charge. They kind of support that education and just trying to get that skill set out to the community so they can kind of start dabbling in design. And it's been really successful. We just had a class last night.
Very nice. So what's your typical age of your class? I mean, are you helping out kids here?
Yeah, it's kind of neat. We're seeing kids from high school kids. We do limit it to high school, nobody younger. But then we're seeing it up all the way up the gamut up to like in their retired. They're retired. And a lot of people I find that if they're retired, they're tinkerers already.
Right.
They have a 3D printer bot or something like that. So they're actually using it to create original pieces themselves.
Nice.
Yeah,
And right inside your fab lab.
Yeah, right here. So we got a couple of things printing actually still from overnight, and it's been great. The replicators are great. The SolidWorks has been great. Doing SolidWorks works seamlessly with the printers as long as you're exporting as an STL.
Which I hear is very important.
It's very important.
It is.
Very
It's very important. We don't have the kind of the big capabilities, but because we're only get down to 100 microns per layer. But most people are using the coarse or fine resolution settings on that STL exporter, and I think it's fine is probably beyond our resolution. But everybody's been happy with it. So
that's awesome.
Yeah.
It's exciting to hear from you, Mike, because it really goes to show you what people are doing out in the world using these 3D printers, using SolidWorks. It really gets me excited to work at CADimensions when I get to talk to people like you.
Oh,
yeah.
yeah.
Library than my own. I grew up.
I remember reading books, so I wish I had this to kind of inspire me as a kid, as a high schooler. It's very cool.
Yeah. It's been kind of neat seeing some of the kids come in. They've probably right now the stuff that we've seen with STL, part of being made in SolidWorks was we made a bearing plate and a bearing in one of the classes. So, but two of the kids, they were actually the high school kids. They came in, printed them out, and it was kind of neat to see them actually hold it in their hands, and they created it.
Yes.
So it was cool.
Excellent.
Yeah.
You got any exciting projects coming up over at the Free Library?
Well, again, one of the things is the adult robotics clubs. So if people are local around Fayetteville, if they're interested, the adult robotics club meets, and they are actively working on this mascot. That's the biggest thing. We do have some projects coming up over the summer, part of our reading program, that are going to use actually the SolidWorks and the 3D printers, and we're going to do a little inventor camp for teens and young adults.
Awesome.
So that's kind of coming down the, yeah. So who knows? So it's going to be very free reign. Anything that they see that enhances or changes the ergonomics of something already made, if it's a completely new design, a completely new invention, or hopefully this program through the summer is going to help kind of get those creative juices flowing for people in the community.
Awesome.
Yeah.
And so if I'm a Fayetteville resident, so what do I need to do to sign up for these or to attend?
Yeah, all you have to do, if you have a library card, come on down. What we could do is
I'm halfway there.
what we could do is we could set you up for a class with SolidWorks, and those happen they happen 2 times a month. We can also set you up with a one-on-one. It's usually with either myself or one of the other librarians. And what we'll do is we'll actually train you on the MakerBots, just so you're familiar with the software, what not to touch, what gets hot, things like that, how it works. And then you become certified. Then you can come in here, and we just charge 5 cents per gram for the pieces. And yeah, it's really not bad. I mean, we keep like 10% infill on the machines, So kids will come in with like $1, $2, and they're here all night. And actually, that's what's still printing out behind me. So whether it's Halo figures that they're making, or like I said, we're starting to see those original parts that are being made. So that's exciting, you know.
That's pretty cool.
It's very cool.
Well, I appreciate you coming in today, Mike, and sharing your insights of SolidWorks and 3D printing and the MakerBots you have there.
Yeah. Well, thank you. And
As
if
always.
anybody's
Oh, go ahead.
Yep. No, I say it. And if anybody's interested, they can it's just to take a look at one, you know, before they kind of jump into things. We have the software there, so you know it's here, so you guys can check it out.
Awesome. Well, as always, if there's anything CADimensions can do to help you guys, we love supporting the community.
Yeah, you guys have been great, so thank you. Thanks again for inviting me.
Of course. Well, thank you, Mike. We're happy to have you.
All right, great.
All right, Jeff. That got me invigorated about 3D printing. I'm ready.
Very exciting topic.
However, while Mike was talking there, I answered a text. I got to be honest.
You weren't driving.
I was not driving. I was here the whole time. I showed my prototype to my boss, and he reminded me that I forgot a gasket filling. Unbelievable. It's part of my design. I have it. It's in the prototype, but I forgot this rubber-like gasket that goes here. So I need some feedback on what I should put there. What can I print in?
Well, tell them. We have something for you.
No.
Yes, we do.
You're a man with many answers.
A lot of answers. So back to our material slide. On the other side of the fence, back to our PolyJet stuff. Like I said before, we kind of get into some different flexible materials. So you can see this shoe here is a very flexible material, which a lot of people are using to simulate gaskets for prototyping.
I can see that.
Yeah, so it's very cool. So we have different shore values on our tangle materials, but one of the neatest things that our PolyJet systems offer is, well, within our PolyJet family, we have what's called the Connex technology. And what that means is the ability to print multiple materials all in the same build, all at once. So we're taking one print job. So we're taking two base materials, and on the fly, we're setting them down in a pattern to simulate different types of materials onto one product. So speaking of the Halo guy,
I know Mike brought up that the print Halo guys.
This guy right here, if you can see him, all the different colors were actually printed all at once. So this was a combination of one of our rigid materials and one of our flexible materials, and we had 14 different types of materials we were able to print all in one build. So it's a pretty cool, pretty impressive technology. What it also allows us to do is to get a wide variety of shore values. So if you have different gaskets that you need to prototype, you can choose from many different shore values so you can get that right fit for you.
Perfect. So it can be flexible enough to fit in my gasket hole here, but rigid enough to actually support everything going through it. That's pretty cool. All right. Now I'm curious. I see there's other PolyJet technology materials out there.
Yes, there is. One of the biggest ones we have is still based on our Connex technology, which is what we call digital materials, which is our digital ABS, ABS Lite.
So this is ABS.
That's real ABS. This is ABS that's simulating.
Gotcha.
So it has the characteristics of it, but it's not a real ABS material like we are on our FDM side.
Cool.
But one of the neatest things about the PolyJet materials is that they're a thermoset material. So they will not melt. They'll actually catch on fire before they melt.
Never melt.
I've seen a video. Very cool. They catch right on fire. And one of the most exciting applications we've been working on, Stratasys has been working on with a lot of customers, CADimensions has been working on with customers, is using the digital ABS material to create short-run injection molding molds. So this allows us to actually build what we kind of call prototype 2 when I need that actual end material. Instead of going out to soft tooling and waiting 6 weeks, I can print something overnight and go out and get 5, 10, 15, 20, 30, 40, maybe 100 parts, depending on material and temperature and pressure, to get my prototype that I need out of that material.
So I can run my plastics in this mold and create my end product.
Yes.
That's crazy.
It's amazing.
And we're seeing more people doing this now?
It is hot application out there. We have a lot of customers that are starting to do it, a lot of customers who are getting into it, are expressing interest. Stratasys actually has a guy. That's all he does.
That's their guy?
All he does is work with injection molders.
I can see why. I mean,
So,
it's got to be a growing industry.
yes.
It's got to take a long time and probably a pretty penny to make just 10 of these, right?
No one really wants to machine that.
No.
No one wants to machine that part at all.
No.
So we can get complexity with ease.
Yeah, because I can make that in SolidWorks pretty quickly.
You can easily make it in SolidWorks, but machining is the difficult part.
Exactly.
3D printing takes that easy.
Understand my job's not hard.
Like I said, I don't really know what you do.
Very true. I'm okay with that. What else you got? What else can you do with these PolyJet tools?
Wow. If we go to the next slide.
Oh, that's my job. I have to do it. Whoa.
Price time.
So,
Price time.
if anyone was on our blog earlier this week, or goes to our blog rather quickly, you'll see that I have a post from Tuesday, the 18th, and in that post it says prize phrase. So the first person I see in the chat or question window to type that prize phrase will win a prize. Do you want to know what the prize is?
What is the price?
The prize is this lovely collage.
Oh. Those are 3D printed parts there, Tom?
These are 3D printed parts and a CADimensions coffee mug and pad. Our 3D printed parts are this bicycle chain with full mobility.
That's right, built all at once.
This is on FDM.
Yes.
We have I broke the wrench. We have a dragon.
Yes.
What was this printed on?
FDM.
Oh, I'm glad I got a fluffer here. And we have a CADimensions wrench, fully functioning.
I'm sorry to disappoint you, Tom, but that was built on FDM.
I'm realizing.
You should have brought me into this to tell you what's thick.
You were out of the office. I did what I could.
I think the most exciting part is the coffee mug. It took me 5 years to get one, so you guys are lucky.
Yeah. So any second now, I'm sure our blog is just flooded with people.
Yeah. No one wants it.
No one wants our coffee mug, Jeff.
Well, we'll wait, and we can talk about what's new.
Fair enough.
We'll talk about what's new.
Our prize time can continue.
So I thought Stratasys was done with the Connex technology.
I mean, they seem to have perfected it. There wasn't much competition out there. And
It was the only one.
They can do crazy stuff with
Crazy
it.
stuff. But just this last year at SolidWorks World,
Yeah.
they released the Object 500 Connex 3.
That's a cool name.
Boom.
Cool name. A lot of numbers. It must be cool. What can it do?
So basically, with the Connex technology, we had two base materials.
And that's how we printed.
And that's how we printed
Hey,
G.I. Joe.
okay.
And
Or G.I. Joe.
Or G.I. Joe. The Connex 3 technology takes it to the next level by adding a third base material. So what we're introducing is a world of color. So we have the first ever multi-material, multi-color printer in the world. We can do tinted color. We can do flexible color. Capabilities to do 500 materials with one system and the possibility to do 46 different colors all at once.
That is outrageous.
It's pretty crazy. It's pretty crazy.
That is crazy. So
That bike helmet, 46 colors in there.
one print job.
One print job.
One print job. That is neat looking. Those are some funky looking shoes. I think I want them.
Nice. That's nice shoes.
Yeah.
So it's pretty exciting. Pretty exciting.
Jeff, we have a winner.
We have a winner.
We have a winner. Who am I looking at? Mark Humphrey.
You won.
Figured out our March Madness prize phrase. Congratulations, Mark.
You just won. A coffee mug.
You won a coffee mug and some very cool 3D printed parts.
Took Mark 5 minutes, took me 5 years.
It took.
It's a big time difference.
he must work harder than
He's
me.
worked hard.
So, Mark, thank you for checking out our blog. I'm hoping all our other viewers are currently on our blog, looking at all the neat posts we have out there. What else you got? You have anything else about Connex 3 or?
I would say, that's what we got for Connex 3. It's pretty exciting.
Pretty exciting.
We got a lot of parts here. If you guys are interested in checking out the colors, come on over to our open house. We'll have a lot of different display pieces. We'll have PolyJet and FDM systems here, so you're free to come on over and take a look at them and see what we got going.
So, Jeff, I'm looking at our table of stuff here.
Mhm.
There's still two more parts that we have not talked about.
Oh, the dragon and the castle?
The dragon in the castle.
Yeah, okay, so here you go.
I'm a child at heart.
Again, you can see the detail we're able to get by building this castle. Pretty cool. A Connex, so we have a rubber roof. I don't know if that would work very well in the real world, but in our fantasy world,
it'd be quiet. It would not work in Syracuse, I'm sure.
And then we also have Dragon. You can see there, painted. One of the great things about the polyjet materials is they can be painted. This was actually painted by one of our application engineers on our 3D printer side.
Nice.
A hidden talent we didn't know about.
No.
He's painted several things now, and he does a good job.
If you come to the open house, you'll see our dragon army.
Yes, we have a lot of Dragon.
A dragon's a very cool file type because you get to see the details of the scales, of these horns, of his gnarly teeth. He's a pretty mean-looking dragon.
It's frightening.
He's less frightening when he's teal and green,
Yes.
but he is still pretty frightening.
Keep me up on that.
All right, guys. So with that, I think we're down to questions. Let's see what we have. What is the resolution for temporary injection molds? So it's got to be the same resolution as the printer, right?
Yeah, as far as the minimum wall thickness, it is 0.06 millimeters on the polyjet side.
It's pretty small.
It's pretty small. Yeah.
I mean, some of the details that you're getting into, a clear part on TV isn't great, but I mean, you're getting down to the nitty gritty of the details in this injection mold.
Mm-hmm. So complex parts are very easy to do. Your temperatures for injection molding are going to range between up to 300 C, and then the amount of shots you're going to get on a given mold will depend on the pressure, temperature of the material that you're molding. But it is a well-developed application that we do have a lot of information on. So if you are interested in it, please feel to contact me, and we can get you the white paper that Stratasys is made for.
Very cool. Other questions? Andy DeLore cannot hear. So
That doesn't matter.
No. I think we fixed that.
Yeah.
So we answered that one. Any other questions out there from our studio audience? I think we were so
Good.
efficient.
I told you,
we got
every time
all
I
the
do one of these
information
things,
on
don't
it.
ask
We have
questions.
no more
That's nice.
questions.
Full of information.
Means it's the perfect PowerPoint and explanation.
We covered everything.
That's great.
You can say we're done.
In case we missed something,
Or you think about something later.
right, you can always contact us. Our emails are there. You can call CADimensions. You can find us on Facebook or Twitter. You can post right to the blog. You can find us everywhere. CADimensions is everywhere. That sounds creepy.
We're not watching you.
We're not watching you. We're available to help you. So any questions, please contact us. We thank you for joining us this morning, and we look forward to seeing you all next month.
Have a good one.
All right, take care, guys.